and we'll begin with our World Asteroid Day celebration for today.
Good morning, ma'am.
Good evening. How are you?
Good evening, ma'am.
Mute yourself.
Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am.
Good evening. You can have muted everybody. Okay. So we'll just wait for a few more seconds. Good evening, everybody. If all of y'all can hear me, I want you all to show me a thumbs up. Yes? Okay. Okay. So, good evening and welcome. We have something very special for you today on today's World Asteroid Day. I will just share my screen and I will introduce Space India. Megan, what can you see? Okay. So about Space India is the largest pioneer organization working towards development of space science and astronomy awareness in India. It has been changing the face of science and astronomy through path-breaking concepts, services, and programs. Space India organizes more than 20 events for the popularization of astronomy and space sciences in India throughout the year. Space India has had a proficient run in its span for almost 2 decades, and it has favorably executed astronomy and space science curriculum in the Indian education system. It has been successful in running out to more than 1 lakh students annually and serves over 5,000 schools and colleges and universities through its various programming. So as you can see, this is what Space India does throughout the year. And this building that you see is the Chhatrapati Shivaji Maharaj Vastu Sangrahalaya, the museum building that is there in Mumbai. And today, Space India and the museum has collaborated to bring to you this wonderful World Asteroid Day celebration. So this is a little snippet of the museum. We have more than 70,000 objects in our collection. And this is the Little Children's Museum. So without taking any further of your time, I'm going to hand over the screen to Yogesh, who's going to introduce the 2 wonderful speakers that we have for you guys today. So Yogesh, over to you.
Thank you so much, ma'am. Thank you so much for the wonderful introduction about Space India and for handing me over the stage. Now, a very good afternoon to everyone who is present over here to celebrate the Asteroid Day with us, whether it's kids or adults or anyone, whomsoever has connected with us, all the viewers who are watching us live, right? So, my name is Yogesh, and I'm working with Space India as Assistant Education in Charge now. And I welcome our guest speakers, Dr. Ankush Bhaskar, who is a faculty in Department of Space at Space Physics Laboratory of ISRO, and Dr. Narendra Bhandari, who is a senior professor and a chairman at Physical Research Laboratory at Department of Space, Ahmedabad. So I would like to welcome them on behalf of Space India. Now, as we all have gathered here, I hope you all know the occasion. The occasion is International Asteroid Day. So, what is this? Why we are talking about asteroid? Let's understand about this a bit. So, June 30 has been declared as Asteroid Day to run a global awareness campaign. By whom? By United Nations. And here we are, Space India is representing the United Nations, as Space India is the regional coordinator for the same. Now, today we are here to make you aware of the asteroids, which are one of the space rock. I hope you have an idea that in space, in our solar system, apart from our planet and the sun, there are many space rocks. So one of them is asteroid, and we are going to make you aware on asteroids. Now you might be wondering, what difference the information or this awareness about the asteroid will bring to you? Why only on June 30th? How does it really matter? We have a lot of things in our life which is going on, and we can concentrate more on them. Why only asteroid? About the rocks, which are some millions of kilometers away from us. I guess, I guess you might have got some idea about it. Let's understand that. So, have you ever seen dinosaurs in the movies like Jurassic Park, probably in some amusement park, or their fossils in some museum? But ever wondered where are they now? They have existed few millions of years ago, but where are the dinosaurs now? They are extinct. Dinosaurs became extinct because only one yet hazardous asteroid hit the Earth during their period. Now, the whole ecosystem at that point of time vanished. This happened some 65 million years ago. Can it happen now? We cannot deny the probability of it. Yes, we cannot. So, Asteroid Day is the day to create awareness about the enemies, I can say, okay, which are out in the space. Though they are huge in number, they are very far away from us, but we cannot deny the probability of their collision with the planet Earth. June 30. Why especially June 30? Let's come on to the second question. So June 30 is the anniversary of Tunguska blast, Tunguska event, Tunguska tragedy, right? Which happened in 1908, some 116 years ago, which is marked as the largest asteroid impact on Earth in the recent history. Okay, which knocked down all the trees in like 40 miles radius. It was a huge forest and thousands of trees they were down, right? And for more than 10 years, people were not able to enter into that forest. So you can imagine how much devastation it has caused at that time. Thus, it is important to understand about asteroids and the impact that they can cause on the Earth. So for this, I would like to welcome our guest speakers and see, as I said, we have two guest speakers with us. So I would like to welcome our first guest speaker, Dr. Narendra Bhandari sir. And before we listen from Narendra Bhandari sir about asteroid, I would like to let you know a bit about him. So Professor Bhandari is a space scientist and he has done extensive research in several areas of planetary and the Earth sciences. He obtained his PhD degree in physics in 1967. So you can calculate or you can get an estimate that he has an experience of more than 50 plus years in the field, right? So his vast experience, we are going to get a lot of good words from him. He has been the senior professor and the chairman currently of Geosciences Division at Physical Research Laboratory, which comes under Department of Space at Ahmedabad. He started ISRO's Planetary Science and Exploration Program, which led to India's mission to Moon and the Mars. I hope you know about the Chandrayaan-1 mission and the Mars Orbiter mission. Sir is currently working to study the Moon and the meteoroids and cometary and asteroidal impacts on on Earth and the mass extinction on Earth, alongside various other fields in science. Throughout his whole career, he has been honored with several awards for his contribution to science. Some of them are Vikram Sarabhai Award for Planetary and Space Science in 1976, Certificate of Special Recognition by NASA, National Mineral Award of Government of India. He has got the title of the Space Visionary by International Society of Space Visionaries, USA. He has got the Outstanding Achievement Award in 2010 by ISRO. And he has also got Marwar Ratna Samman in 2016 by Mehrangarh Museum Trust in Jodhpur. So I would like to welcome Sir and I would like to hand over the stage to him. Let's listen to Sir.
Thank you very much. I'm so happy that so many young children are interested in learning about asteroids. You know that hundreds of rocks, thousands actually, fall on Earth every year from space. And every day, hundreds of tons of this material comes as dust. They are all falling from the sky. And with them, they bring to us very important
recording in progress.
Material, chemicals, organic compounds, carbon, water, all this has come outside, from outside the Earth, and they bring it whenever we need it for our survival, and evolution. But at the same time, the interplanetary space, that is, we have these 8 planets and many satellites all around. There are 2 belts, 2 belts of rocks. And let me share my screen here so that you can visualize that we have these planets right from Mercury to Venus, Earth, and Mars, and Jupiter. Jupiter is by far the biggest, as you know. But in between Mars and Jupiter, there are these thousands of pieces of rocks floating around. And same thing happens when we go beyond Neptune. There are thousands and thousands of pieces which are going around the sun. Once in a while, they make their way into the orbit of the Earth, strike it, and when they do so, they create devastating effects. So not only they bring important chemicals, carbon compounds, water, etc., to the Earth so that we can live, but they also are capable of destroying the civilization. And as we were told just now, the 65 million years ago, a 10-kilometer size body, a huge body came and hit the Earth near Gulf of Mexico in the United States. It fell in water, and it created a crater which is 300 kilometers in diameter, a huge one. Several cities can be, equal to that crater. Now, when this happens, it is not just that it destroys whatever is there at the impact site, but it creates a large number of chemical processes which destroy the civilization all around the globe. And it is estimated that about 70% of all living species, mind it, I'm not talking of living creatures, but species got extinct. We call it a mass extinction event. So what happens actually when this body comes and strikes? First of all, the energy is enormous because it comes and strikes the Earth with a velocity of tens of kilometers per second. We are familiar with very small velocities. Our car goes at, tens of kilometers per hour, but it is some 3,600 times faster than that. So much energy is deposited. It is equal to something like 1 million tons of nuclear bomb which was thrown on Hiroshima. So this is a real danger that this can happen again. And therefore, we are here to observe, or let me say, bring awareness about the danger which we face by impact of these bodies. So as I said, 40,000 of tons of dust falls every year. Thousands of small stones fall every year on Earth. 100-meter size fall every century. And the Tunguska event, which is about 40 meters in size, fell more than a century ago in Siberia, and it affected all the forest region. Every tree was, devastated. And a bigger one, a 10-kilometer, is estimated to fall every 100 million years. And they play very important role in our life. So that is what we are supposed to understand, that you see, this is the picture of Tunguska event. You see these trees. It seems that this body burst in air and produced so much pressure that all the trees were knocked down. Thanks to the nature that we have a thick atmosphere. This is the picture of the moon. If atmosphere was not there, Earth will be like the cratered surface of moon. Everywhere these big pits produced by impacting bodies. But here on Earth, we are safe because we have a thick atmosphere. But still, the effect is very devastating. So you see, sometimes one can go out and recover these stones. And that is where I'm really interested in your participation. We can all become collectors of meteorites because thousands upon thousands fall on Earth every year. And if you keep yourself aware of this event, that means if you keep your eyes open and you can listen to this sound of these impacting bodies, you can go and collect it. So there are stony types, there are iron types, very heavy, and sometimes they fall in ice and make a crater, and they are accompanied with a fireball or a glow or a trail in the sky. So that is how we know. Now, from their study, when we get these samples in the laboratory, we can analyze them and we can learn a lot of things. For example, we learned that our universe was created 13.7 billion years ago. Our sun formed from a molecular cloud 4.5 billion years ago. Earth was formed little later after the sun was formed. And the life on Earth began 3.5 billion years ago. And this life, which is the, which grew with great difficulty over billions of years, can be destroyed in one instant if a body comes and hits the Earth. This is the dinosaur event. Dinosaurs were roaming. They were not aware that something will happen. This thing came, fell in Gulf of Mexico, and the dust fell all over the Earth. The sunlight was shielded. We never got enough sunlight, so all vegetation destroyed. There were forest fires all over the Earth, and so on. And all the shells in the sea dissolved because of ice, because of acid rain, and so on. Now, we have identified about 200 such craters on the Earth. There are 3 or 4 in India. The famous one is Lonar, of course, near the Ajanta caves. There is one in Ramgarh in Rajasthan. There is another one in Vindhyans, that is Dhala crater. There is one more in Kaveri basin, and so on. So these are real, real craters formed by impacting bodies. And this is the picture of the Lonar Lake, It's about 2 kilometers in size, now filled with water. But this was created by something coming and hitting. So to save ourselves, a lot of efforts are being made. And we have also learned lots of things by studying them, what is the universe made of, when the sun and how it was formed. What are the organic molecules? Some of them bring organic molecules, amino acids and fatty acids, chemicals like methane, ethane, and so on. So lots of things have happened, and we study all these meteorites, and this is an ideal case of public and private participation. You can also be aware of this, and you can collect rocks, and we can learn a lot about our history, our Earth, about our solar system. This is always accompanied by a light and sound show. As I said, there's a fireball, a ball of fire traveling through the sky and makes all kinds of of sound in the sky. And then it, of course, falls and makes a crater. Now, how do we identify them? Because they are heavy, their density is very high, they are magnetic, and they smell of sulfur. Some of them, if you smell them, sulfur H2S smell will come out, and there are many ways you can identify them. But unless we make detailed studies, and study these rocks. You know, these small balls are found in them. These are called chondrules. These small balls I have isolated from one of the rocks. So there is a lot of science to learn, lot of information to get. And the way we did in case of a rock which fell in Dajala is took these school children, you know, they really helped. About 200 students, all walking in a single file through about 20-kilometer area, looking for these little stones. You see these young boys here in the background. The picture is not very clear, but with their help, we collected 500 stones and studied in the laboratory. You see these young children having their own rock from the sky. So we spend millions of rupees, billions of rupees going to moon and bringing sample, going to Mars, still not got the sample. But nature is very kind to us. They bring the samples free of charge on our doorsteps, and we can study and learn a lot about these rocks. So when the comet comes, the comet is a big one. It has a tail which is millions of kilometers long. It leaves a river of sand in the sky, and they keep on falling on the earth slowly. So we can collect big ones if they reach safely to the earth. Now here's a picture of a meteorite which we found recently, about 5 years ago, 6 years ago, near Jaipur. This is like a charcoal, black, very fragile. It was about 3-kilogram body which came and hit in this place in the far, created a small crater and broke. But in this we found chemicals which give rise to our, which are required for life processes like phosphorus, carbon, water, and so on. So they have enormous energy. They heat the atmosphere, then dust is produced, then acid is produced, then forest fires are produced, and so on. And all the civilization can be affected. So this is a real danger. I can't tell you when the next one will fall, but it is bound to fall someday or the other. So various space agencies have observation programs. They call near Earth objects, NEO observation programs. I have listed about 8 of them. India also is trying to look for these things so that if we know in advance that these big rocks are coming, we can, be aware of it. We can do something to save ourselves. So the big question is when the next one will fall. So they say in 2029, far away, we can relax. It is still many years away. It's a 325-meter object. And there's another one which will fall in 2036. So you see that the danger is real. But when it will fall, we cannot tell. So what NASA has done is, and Japan also has done, that they have sent missions to these NEO, the near Earth objects, to collect samples. And the NASA sample has brought this, has collected this sample from an asteroid called Bennu, which is going very close to the Earth. It's going to fall on Earth one day, and it's already on way back. It will land on Earth in 2023. That is next year in September, and we are supposed to study these rocks so that we can understand how it will affect us, how the civilization will be affected, and how it was formed, and so on. So my urge to you is you become a meteorite hunter, collect meteorites when they fall, because they fall all the time. And this is the picture I wanted to show. Emperor Jahangir, he was not very educated man, but he was presented a meteorite which fell in Banaras made of iron. And he found out that this iron doesn't rust. So he asked his people to make a dagger for him. And this is the dagger which is preserved in Delhi Museum. The beauty about it is it has got nickel, so it never rusts. So I would say become a meteorite hunter and collect sample. And if we can study, we can learn new things about our past, about our origin, about our Earth, about planets, and also we can save ourselves possibly from the imminent danger of their hitting us. And that is what Asteroid Day is all about, to become aware, to spread this awareness in public. And NASA and our ISRO and many other space agencies in Europe, China, and Japan are working to find out that if they do detect something coming, how we can save ourselves. We can move it a little bit off the trail so that it will not hit Earth, but it will pass nearby and we can save ourselves. So thank you very much. I just wanted to share this information with you and invite you to join our group. We have a astro enthusiast group which is involved in looking for meteorites, collecting them and studying them. And this is a perfect example of public and private and citizens and scientists participation and do high level of science with these rocks, because they come from far away, some even from outside our solar system, some from cometary belt, which is 100,000 astronomical units away, and some from Kepler's belt and some from asteroid belt. So I invite you to join our group and look for these rocks, and let us study together and try to save the imminent danger which they pose to our whole of civilization. Thank you very much.
You're welcome, sir. We all are overwhelmed to hear such an informative presentation, right? And some amazing facts, which I never knew before. Okay. And yes, so to start with the questions, sir, kids have asked the first question as you have discussed about the Astro Enthusiast group, right? So all of them, they wanted to join the group, but they wanted to know where exactly is this group and how they want to join. This is the first question, and I'll put the other questions.
Yes, you can write to me on my email or my telephone number. My WhatsApp number is 98240777890. I think you can flash it sometime. And you are all welcome to join. We have a large group of experts as well as amateurs. And there are lots of trails seen. Even last week, there was one in Nagaur district, one in Ganganagar, and so on. So we are looking for meteorites, and we find the old meteorites and new ones. And I myself found about 20 meteorites during the last 30, 40 years. And we have studied and learned a lot of things. But that will be a big talk, a very technical talk. I don't want to go into it. But the amount of information one rock contains is enormous. So there are people who pick up a rock and spend their lifetime studying it. And, there's a great joy in learning new things. So you please join. You are most welcome.
Thank you so much, sir. Sir, next question, it has come from Chinmaya Krishna. And the question is, they've asked that, is it true that some metal asteroids are remnants of core of planetoids?
Right, that is true. You see, these asteroids, many of them are not like what they were there when they were formed. They got melted. There is a heat inside, heat due to radioactivity, which again we have learned from meteorites. So when they get heated up, they melt, the iron separates and become the core. And this stony material, like in our Earth, we have core of iron. Same thing happens on asteroids. And once in a while, when they are hit by another asteroid, they break, and this metal, which is mostly iron and some nickel, that they come to the Earth, and that is what makes the iron meteorites. So yes, it is true that many of the asteroids have got molten because of collisions, and they have a core of iron, and then they take hundreds of millions of years to reach the Earth. We have got 24 rocks from Moon in our collection, which have come from Moon. during the last, a few million years. There are 20 odd samples from Mars which have been collected from Antarctica. They just get collected there on the ice. So this is a very, exciting subject and a lot of fun to look for them and hold a rock which comes from the sky, you see.
Wow, sir, amazing. Sir, one more question. See, the question starts from what are asteroids, but we have already got that answer. There's a question in the series. Question is why there is a gap between Mars and Jupiter, and why most of the asteroids are in between them. Second point is why there is a belt beyond Neptune.
Sir?
You see, the point is the way our planets are formed is in multiple stages. What they say is that first there's a cloud in the interstellar space, a molecular cloud, which is very huge, a little bit dense compared to other clouds, little bit hotter. And if there's a star nearby, it can trigger the collapse. It can send shock waves, so everything gets compressed. And from that arises the sun. And then small bodies are formed. Something like 30 kilometer side is the people say protoplanets, protoplanetary bodies. Thousands and thousands are formed. And some of them get together and convert into planets. But most of them are left behind. So most of them are left behind. Some are between the orbit of Mars and Jupiter, because Jupiter is the big fellow. It is the biggest planet. It doesn't allow things to come in. It captures everything and grows. But inside of Jupiter, these rocks which were left out, some are broken planets also. So broken planets, original planetoids out of which planets were formed, they are all there. Now the Kepler belt, which is outside the belt of Jupiter, you see, everything doesn't come and form planets. Lot of like you prepare something, lot of waste will be there in any process. About 100,000 astronomical units away. One astronomical unit is a distance between sun and the earth. There we have a big cloud we called Oort cloud. One Dr. Oort was there who found that there is a cloud there. That is the limit of our solar system. And that is made up of, we call it sand and ice. They are made of sand and ice. When it comes inside the solar system, the ice evaporates and sand is left. And some of this is captured because of planetary perturbation and formed long time ago the Kepler belt. So Kuiper belt, I'm sorry. Kuiper belt is formed, it is beyond 50 astronomical units. And actually we didn't know about this long time ago because it is all dark, not much sunlight is falling, it is not reflected, our telescopes can't capture it. But now we know that there is a very huge belt of these rocks there. And once in a while, they find their way and come and hit the earth. Now, if we are smart, we can go and collect it and study without going to Kuiper's belt and collecting it there, wasting a lot of money. They are available right on earth. So there is a asteroid belt, there is a Kuiper belt, and there is a Oort cloud. These are unfinished planets. They never got to form planets. They still exist as the original bodies they were.
Okay, sir, last one question. Okay, actually, I'll combine two questions in this. First one is, are asteroids the reason that there are oceans on Earth? And second question to this is, are asteroids responsible for life on Earth?
Well, asteroids, there are, Ceres is the biggest asteroid. And this Bennu, for example, I talked about the asteroid of which we are going to get a sample very soon next year. It is supposed to have a lot of water. Even this Mukundpura place in Jaipur, where this meteorite fell in 2017, had 8% water. So when the earth was formed, they say it was very hot, thousands of degrees. And all the water and carbon and volatile compounds which evaporate at low temperature evaporated off. But when the earth cooled, all these bodies came and hit the earth, and that water was preserved. And that is what we find in the ocean today. So oceans were not formed by the craters, by impact. Oceans are formed by another process known as plate tectonics, by which continents move from each other. The earth, we think it is a solid ground, but it is not. It is like a boat moving away from each other. And these oceans are formed because America went away from Europe. The Atlantic Ocean is formed. China went away from America. That is, Pacific Ocean is formed. They are all moving like a boat in a ocean. And water from them is brought by these asteroids. So water we have got is extraterrestrial, coming from outside. So this is true that water has come from outside. And your other question was related to this. Can you repeat that one again?
Second question, just a second, sir. Yes, are asteroids responsible for bringing life on Earth?
Well, asteroids are responsible for destroying life on Earth. But little dust, as I said, 40,000 tons come. They are responsible for bringing life to Earth. It is now believed that life is formed in molecular clouds far away in interstellar space, because there you have ammonia, you have methane, you have water, you have ultraviolet rays, you have solar radiation. All this combine and form these organic compounds like sugars and amino acids and fatty acids and aromatic hydrocarbons and so on. And then life emerges from them, and riding on this dust, they come on Earth. So this is called the theory of panspermia, that life is everywhere in the universe and is brought to Earth from outside. So small ones bring life and big ones destroy. This is if you want me to conclude in one sentence, they both have a role to play, but they are both important roles. One creates and other destroys.
Wow, thank you so much, sir. And with this last statement, I guess the student who has asked me the question, why are asteroids important or space rocks important, you have also got the answer to that. Now, so we'll move on into this webinar, though I have lots of more questions in this. Right, so I'll move on to the second speaker for the day. And the second speaker for the day is Dr. Ankush Bhaskar. He is a faculty at Space Physics Laboratory, which is under Department of Space by ISRO. Ankush sir's research is mainly focused on solar terrestrial physics. He is presently working on the Van Allen radiation belt. He is curious about any physics problem and likes to explore new things. So today we are going to get some very amazing insights from him. He mainly works in observation science, and he loves to make the models of those scientific concepts. He had delivered multiple talks at various events and has been the editor for multiple magazines and articles. He is a lifetime member of Astronomical Society of India and a member of American Geophysical Union. Sir, now I would like to hand over the stage to you. Sir, you have to unmute.
So please unmute yourself.
Yeah. Okay. I was not able to unmute. Okay. Now I can do that. Fine. Okay. Can you hear me properly?
Yes, loud and clear, sir.
Yeah. Great. And my screen is visible, right?
Sir, There is okay, yes, now it's
Yes, your
visible.
screen is visible.
Visible, right? Okay.
Yes.
Yeah. So first of all, thank you, Space India, for inviting me to share some excitement with young crowd. I always like to interact with students and young kids because, okay, I get to know new questions, which sometimes I don't know answers and make me think. So I work in space weather, not exactly asteroids, but as space now era coming up and lot of space missions going for planets and asteroids. So space weather has become very important to understand its impact on spacecrafts, human, even including asteroids. So I will be starting here. So that's what I will be talking, some basic introduction on the sun, what is our sun, and then what is the space weather at all, and how does it interacts with the planets or asteroids, and slightly some hint, just a very glancing touch to the electric environment of asteroids induced by, of course, space weather, and I will end why we have to study space weather for these asteroids. So let's start with like this is I like to visualize, just go back in very long time, ancient time, or when humans were just first and arrive on the planet, and they were looking at the starry night, the meteors, comets, and of course some impacts some civilization might have witnessed sometime back, small meteorite falls and fireballs. So as a human, we have been always curious and wondered about these cosmic phenomena because they shape us and they make us what we are. So not only looking at that, just like few thousand years back, also if you go, we have Mayan civilization. As we wondered about the sky, we have wondered about the sun, because sun has been a main source of the life force on the earth. And so you can see here the Egyptians, like sun god is shown here, and Egyptian king. And similarly, here is also Indus worshipping the sun god. So sun also has a played very critical role for a life, and even as a culture it evolves. So let's look at the sun, how it appears to us is a simple like yes, yellow or orange ball in the sky when we see when the sunrise. So this is a sunrise scene from the Grand Canyon, very beautiful place to witness the sunrise. And we'll see, okay, nothing is much. Okay, sun rises, some just flat days, goes down and set every day, regular stuff. But as soon as we point our telescopes with a specific filters and instrumentation on it, we start looking on the sun's feature. Those are like some, we start looking, oh, sun has some dark spots, and those are nothing but sunspots. And then our curiosity can arise, okay, what are those? We don't see with naked eye usually. Sometimes it's possible, but not usually. And sun is more than just flat days or boring days. It has a lot of things going on, as you see ahead. Yeah. So this is how the sun looks. It's not just simple this. It is a huge big ball, like 7 lakh kilometer. Oops. Yeah, 7 lakh kilometers in the size, and then we have like a temperature about 6,000 degrees Celsius surface temperature, and it has a core which is around 2 crore degrees Celsius, fusing the hydrogen, burning the hydrogen, and producing helium and radiation what we receive at the earth. Plus, if you look at the outside of the sun, you will see some loop-like structures, and those are nothing but magnetic fields. Like the sun is a huge bar magnet, and that's why it becomes very interesting to study. Even the sunspots are due to the strong magnetic field occurring on the sun. So this magnetic field sometimes erupts, and they throw the radiation, not only like electromagnetic radiations, but hot gas from the sun, which we call plasma, mainly electron and ions, get hurled towards the earth, and it can impact the earth very badly sometimes. So look, we'll oops. sorry, some animation is okay. So the sun is emitting, as I said, a gas, and it's continuously emitting every second, every minute. You are getting large particles, a huge stream of particles coming from the sun continuously, and that is called solar wind. Like we have a winds on the surface of the earth because of air motion. Similarly, interplanetary space, the space between the sun and earth, is not actually vacuum or empty. It's filled with this charged particle or hot gas from the sun, and it's coming and affecting each and every planet. So this is discovered in, by 1958 by Parker without observation. Observations were done later. He hypothesized there exists a continuous stream of particles coming from the sun, which is the biggest discovery, understanding like sun that just doesn't give you light, but it is even sending some particles towards the earth. So I will go ahead, and not only we have a continuous stream of particles, sometimes we have a transient stream of particles. Oops. It is not true. Okay. That's not good. Okay. Fine. I think some animation is not. Okay, it's there. It's loading.
Excuse me, sir. Am I audible? Ankush,
Yeah.
sir?
Yeah, can you hear?
Yeah, sir. I guess there was some network issues, right? So two things, sir. One, can you please repeat the last statement, last 30 seconds, what you have spoken just about? That is first answer. Second thing, can you please reshare your screen? Because there's a black block which is coming in front of the screen. Okay, so when you just like reshare your screen, at that moment there's an option. At that moment there's an option. You don't have to take that option. There's an option of like you need.
Okay.
Can you please stop sharing your screen once?
Desktop. I did that, and I will do share the desktop. Will that help? Is it okay now?
So we can still
so right now only the same screen is visible, the discovery of solar wind.
Yeah. Is it okay now? Changing? I think it is little slow, or can you hear me, right? So I am in connected, right? I am connected. Hello. Oops.
So when you share the screen, don't check the option for optimize for video clip.
Okay, I didn't do anything that. So can you see video now playing?
Yes, sir. Yes, sir. Now we are on the right page.
Okay. So I just, I think I left here, right? This was, you didn't hear, I think. Okay. So as I said, there is a continuous stream of particles coming from the sun. And actually, it is predicted by Ivan Parker. After him, the solar Parker probe is named after him, which is touching the sun, now almost closest spacecraft ever flight by humanity to the sun. So he postulated there is a possibility of continuous stream of particle, and afterward it is confirmed by observation. But not only this continuous stream of particles coming from the sun, even we do have some explosive event coming from the sun. Those are called like type a nuclear type explosion or bigger than nuclear explosion occurring on the earth. So this is like a CME, we call coronal mass ejections or something, which is a huge large plasma coming from the sun, and it interacts with Earth's magnetic field and creates beautiful lights. Those are called aurora, if anybody is aware. Mainly those occur in North and South Pole. So sun is even giving this type of sudden transient events. So as sun, you go back, this is a present current scenario. Sun is active and affecting us through the space weather interaction. But even if you go early sun, young sun, when sun just formed and our planets and asteroids were taking birth, sun was very active. So space weather around solar system was very harsh because solar wind was very fast. Lot of explosive events are occurring on the sun. So they are affecting all these planets and small asteroids when they were just condensing that time. around 4.5 billion. The sun was active and giving out a large density plasma or hot gas from the sun coming to this planet. So this asteroid was floating, and asteroid also got induced by these magnetic fields and generated some like bar magnet type magnetic field, their own magnetic fields, which is frozen in these asteroids later on when they condense. And harmful radiation from the sun always continuously were flowing that time. Those are called solar energetic particles. The intensity was very high when the sun was young, and that also has affected the asteroid formations. So this is how the cartoon looks like it affects how the sun affects everything around in the solar system or heliosphere, what we call. So nothing is untouched by the sun or harsh sun whenever it is violent. So it affects the planet, Earth, asteroid, Jupiter, Mars, Venus, Mercury, everything, comet, floating, dust floating in the solar system. Everything interacts with the charged particles coming from the sun, and they get charged or ionized sometime like that. So let's come to the asteroid. Already Bandari sir has explained a lot about asteroids. So my job has become easy. So you're aware what is asteroid. There are no asteroids, just to completeness I am presenting here. So we have a main asteroid belt here sitting. Then next we have a Trojan asteroids around even Jupiter. And then wood cloud and all go away from the sun. And these are the tentatively how they look. You can look at very sharp images. They have a crater, small pits on these asteroids, and they look like very pristine in nature because no weathering in space almost due to water or air, because space is empty, devoid of these air flows like Earth. We have rivers or monsoon like stuff. Nothing is there in this empty space, but still there is like a solar wind, and it does impact. Even it is very tenuous, it's like a perfect vacuum on the Earth, still some charged particles are there, and they do affect going into the interplanetary space. So we consider Earth like a spaceship going around the sun, and other planets also like a big spaceships going around the sun. And like we have a sea, similarly we have a sea of this hot gas coming from the sun. So like that, how you can see this structure is formed, bow type structure, and similar structure as like ducks when they are going, they form like bow type structure. So same thing happen with asteroids or even planets. So look at this cartoon. This is suppose some planet or our moon, and there is asteroids, and it is floating in the empty space almost, and there is a charged particles coming from the sun, and they are interacting, wrapping around the body, celestial body, and forming a bow type structure. Similar like this, you can resemble to this ship floating in a sea. So similar like that, this asteroid floating in interplanetary space where solar wind continuously flowing. So this type of interactions are always there, and what they do, they generate some magnetic fields around it, trap the magnetic field, and some high energy particles are generated, harsh radiation is generated to this, which is very dangerous. If we go close to the asteroid, we have to be careful, because where you are going, what part of the asteroid, it will also matter. And what type of composition of asteroid or planet also impacts the interaction of this space solar wind with the asteroid body. So like as I said, there is no weathering. Weathering on the Earth is like typically broadly classified mechanical weathering, like cracking of rock, breaking the rock in pieces, or physical weathering. We have water is flowing, winds are eroding, causing the erosions, or sometimes like a biological or chemical weathering, which like plants are affecting the rocks, and they are destroying their real nature, even physically or chemically. So this type of weathering is very common on the Earth, and that's why we do see such structures. They look beautiful. Such thing in the space, but interestingly, we have and that interacts with this asteroid. And what we have observed is that when solar wind interacts with the asteroid, it changes its color, or it causes a tanning, you can say, tanning type, right? They become more reddish. Okay. Solar wind is continuously this charge particle are hitting the surface of the asteroid and causing this reddening type scenario. This is problematic because we want to study the meteorite sample, like Bandari sir explained. We collect the meteorites very cheap, like sitting at the earth we get beautiful samples of these asteroids and meteorite. But then when you want to connect them, okay, like if you study the elemental composition, what mineral they are made of, and you want to study the asteroid, then how do we do whether which asteroid it belongs to? Suppose you want to connect somehow, then we take a light, reflected light from these asteroids, and gather the spectrum and to correlate with the observatory these samples we have collected on Earth. But the spectrum get deteriorated by solar wind, and that can cause a big issue, like one-to-one relation we cannot do. So we have a systematic problem in our understanding of asteroids and meteorites coming on the Earth. So solar wind interaction needs to be understood, or interaction with asteroid needs to be carefully taken care to build this relationship. Another is big stuff happening in the space is like we have a sun radiation continuously, like light coming from the sun, and this sun, when it has a UV radiations and all sort of all radiation coming from the sun, it actually knocks out the electron in the day side. Like this is a moon here. So for example, I have shown here a moon, and it takes out the electrons the moon, and that's why the surface become positively charged, and whereas electrons they go towards the night side, and here you have a negative charge. So you have a very strong electric field or voltage generated across day and night of the moon, and that could be very harsh electric fields and cause a lot of dynamics on the moon. Similarly, does happen with the asteroids. So asteroid does become like a battery. You know, we have a battery which we use. So same thing, they get positively charged of asteroid, and night side become negatively charged, and the voltage can go up to hundreds of volts. And this electric fields can have a very harsh effect. Suppose we have going landing on the asteroid, or human suppose in future plan to go to there. So we need to understand what are the electric fields, how the sun is interacting with this asteroid, so we can map these electric fields and find out the right place to go and dig the asteroid, or whatever. So that is a very important, which is a new field, like not much is done in this, so which is evolving now. We are trying to understand how it interacts. So that's what, like here, as I already mentioned, the spacecraft is already has collected this collected sample from the Venus surface, and of course it has encountered this one electric fields on the asteroids. Have observations to study their impact. So just come to this most maybe last slide. So we have to study the space weather, as it is a new topic, and it is getting the interest from all over the globe. Why space weather is important? Because as a human, we are explorer. We will fly. We will go to another asteroids, other planets sometime. Already moon has conquered by human. Next is landing as a human, other planet, asteroid. And as we run out of our resources on Earth, maybe people are very much interested, or business people are very much interested to do mining of the asteroid, because these asteroids contain very precious elements which are very rare on the Earth. So that interest is going to come, or some efforts are going to be done for that in future, and some want to have a technology like that. They just go and fly, capture this asteroid, bring back to the Earth, like that. Some exotic ideas do exist. So that time we need to be very careful, because as I mentioned, we have so when you are landing or human, if if we don't take care, it could be hazardous for us. And even when we go to space, we don't have Earth's magnetic field, which also protects us from the harsh radiation. But this is empty space without Earth's magnetic field. Like electrons and protons, and sometimes sun can be very violent. We need to give a forecast. Like suppose you take a ship and we need to give a forecast. Similarly, when you go to asteroids or planets with astronauts or spacecraft, we need to give warning. Oh, okay, there is a
Yogesh has
Hello, ma'am. It seems like there is some technical
network
issue at Sir's end.
Yes. We can wait for like a minute.
Yeah, we'll wait for 2 minutes.
Yes.
Meanwhile, I guess Narendra sir is here, sir. We have a few more questions from kids. Okay, Ankush sir is here.
Okay.
Ankush sir, can you hear us? Just a second. Yes, sir is back. Sir, you are not audible.
Sir, I think there's a little network connection from your side. If you can switch off your video, maybe that would help with your internet connection. We can try that.
Ma'am, sir's audio is not connected.
Yeah.
Okay, done.
I have
okay,
asked.
I was not able to unmute. Oh,
Yes,
I
yes.
think I lost it between. Is that was? Oh, no.
Yes, yes, yes.
Sorry
So-
for that. I have, I think, very bad internet today.
That's okay.
It's okay,
we
sir.
can keep
So where did I
your
lose?
we can keep your video off and your audio would be on, and maybe your screen sharing will work. So that should work.
Okay.
That might help.
Yeah, but where did I lose the? Can you tell me which slide I
Yes,
was?
sir. So you share the screen. I'll let you know.
Okay, okay. Oh, no, sorry. I was speaking with myself.
It's okay. That's completely fine.
This is problem with online sometimes.
You have
Okay. Why unstable?
yes.
Okay. Sir, it's here. Yes, sir.
Yeah.
So you have discussed this particular part, sir. You were about to like discuss this. You have discussed this also. You have discussed this also, sir. This is also done.
Okay.
You were on this slide.
Oh, okay. This was the almost last slide. So, okay.
Yes, sir.
I lost in the last slide. Fine. Okay. Yeah. So just summarize last slide. Okay. So the question comes: why to study the weather? The thing is that, as I already mentioned, you like there are a lot of space missions, planetary missions, for asteroid missions are already on the way. They have very ambitious projects. Like some want to go and mine these asteroids because they harbor very precious metals like platinum or something like that. And some missions want to just go grab this asteroid, bring it back on the Earth because they have a commercial interest. At present, it's not viable, but okay, in I think some decades that will happen. But before going to this, we have to be very careful about space weather. Like fishermen go to the sea, they want to get fish for selling commercial aspects, but actually, if you don't give them cyclone warning, that is very dangerous, right? So similar way, when you're going in the space, you want to go land on the asteroid or bring back, do the mining of the asteroid. We need to know how the interplanetary space is doing, or how the environment of this electric environment, how much charge of electric field exists nearby asteroid. Those conditions we need to understand. Without that, it's a very high risk. So we need to predict some transient events like explosive event from the sun, which are on the way to hit the asteroid. So for that, we need to generate this space weather understanding, how when the sun will become angry and when it will emit some hot plasma, we should able to predict. So that's why we need to really understand this space weather currently for even asteroid in asteroid perspective. So I think I will stop here and thank you.
Thank you so much, sir. I have few questions from you kids. I have discussed a lot in the chat box, right? And I would definitely like to ask that one question from that one slide where that electric field was flowing between the asteroid and it was getting charged from the sun's light. Okay, so kids have asked that can it be or can we use that thing as a renewable source of energy? Maybe a imaginable concept, right? But kids have asked this, so
Yeah, very good imagination. Yeah, but for that you have to go to asteroid, and the problem with this, this electric field do exist, but the scale length, they are in a very large distance. The voltage is across very large distance, so current flowing will be very, very small. Okay, so similarly, like for lightning, okay, you can ask the similar question. There are so many lightnings happening globally, and can we use that to charge something? But we know that there is a problem, like lightning is high kilo thousands of volt, but the current flowing will be very, very small. So yeah, there is a practical issue, but maybe future as we go to space, maybe you people will find out some way to harbor that energy also.
okay. So second question is that's related to again related to the satellites.
Yeah.
That what measures should be implemented while designing any satellites and its structure in order to make it resistant towards solar storms and avoid accidents with asteroids. Actually, they have mixed
Yeah.
two different concepts, but yes, a big question is
Okay,
there.
okay. Yeah, so space weather is like a tricky still because as space era just started and we're still figuring out how to protect. It's like that earthquake is going to come. We suppose even we know we cannot stop the earthquake. Okay, or a cyclone is coming. We cannot stop the cyclone. So only precautionary measures we can do. And for satellite, generally what we do apply some thick shielding by using some tungsten or aluminum shields. Okay, so that shields particle from this high energy electrons or protons coming from the space, but they also have certain limitation because they are particles. Those are called cosmic rays, galactic cosmic rays. The energy is as giga electron volt or TeV. So those type of particles we cannot even stop. So we cannot provide enough shielding, but certain extent we can shield. So that is one taken. So these are called radiation hardened components. Okay. So the instrument, whenever we send anything in a space, we need to make sure they are radiation hazard hardened. So it get less impacted by the outside radiation coming from the sun. So that is taken care. Some precautions we do have. Yeah. And second part of the question is from asteroid impacting. Okay, actually space is filled with these asteroids and all, but as you see in science fiction movies, somebody is driving a spaceship and colliding with the asteroid. It is not that dense. Okay, they are very, very far each other. And if you accurately have our trajectories plotted, mostly will not encounter any asteroid and hit them. Best example, like we have so many spacecraft which are gone outside our asteroid. They have crossed asteroid belts and gone beyond even our solar system, like Voyager 1 and 2. They have gone beyond our even solar system. They have left our solar system and enter in the interstellar space. So they have survived last many 40 decades, 50 decades, something, I think 4 decades, 4 to 5 decades. They are traveling interplanetary space without colliding with the asteroid. But recently, if you look at, there is a James Webb telescope, which is the largest telescope in the space sitting, looking at our cosmos, and it was hit by some small meteorite. Okay, so they are like small particles types, like asteroid, not asteroid, but small particles. They are populated in space, and of course, they can hit our satellites or they can hit our telescope. But if they are very small, then okay, and not moving with very high velocity, then we will be fine. But yeah, there are small possibility of collision of with these small particles always exists. Yeah.
So one last question. Like actually, here I'll combine two questions. One is for ISRO, and one is a general question. General question is that if asteroids they are so dangerous for us, or can be so dangerous for us, why don't we nuke them with the help of some missiles or some nuclear missions? And second question in this, okay, what are the countermeasures which are taken by ISRO, okay, to lower the threat of potential NEOs, near Earth objects? Any countermeasures, anything which is happening?
Okay, that is an interesting question. At present, like even sci-fi movies also project that, right? Some asteroid is coming or comet is coming, they just send some nuclear weapon or missile and just blast in the space. But that may not be that straightforward, because suppose small size coming is okay, most of the part will get burned and some small crater may be formed. But suppose kilometer size is coming, how do we really blast it? Even you blast it, suppose there are chances like it will blast in two chunks. Instead of having one city gone on the planet, you have two cities getting devastated at a simultaneously. So at present, actually, we are not well prepared if something big, very huge size come, because we do, because suppose you send even nuclear weapon, suppose you detonate in on the surface, even the only small part will chunk. Okay, we want to destroy it completely and make small parts, so when they enter in the atmosphere they burn down. But that may not happen, so that need a lot of modeling efforts, theoretical efforts, and this threat is becoming imminent, like maybe we'll encounter sometime. So people, NASA has already this asteroid watch program. They are monitoring near the orbit continuously, but still, like we may miss that. Like recent one, not very recent, when Russia, one of the asteroid or fireball was observed, but that was not seen because it came from the sun direction. So there are many blind spots also. We will miss sometime something is coming to the earth. So this technology yet to be demonstrated. We have not done any demonstration yet, not tested it. Theoretically, we feel it is feasible, but we don't know whether really we will able to stop it. But our one advantage point is that these huge asteroids, if you look at the probability, how frequent they happen. So mass extinction type event or kilometer size event falling on the earth causing the mass extinction in tens or hundreds of million years once in a. So that is a good, until if you get few hundred more years or 100 years more as a human, I think we'll reach the technology to even protect us from asteroids or any huge like cometary impact. So at present, yeah, we are on the way, but not fully prepared. If something comes tomorrow, oh, I don't think we are prepared. Yeah. And
Okay.
anything else you ask?
So
Okay,
these
for
two.
ISRO. Yeah, ISRO. Yeah, about ISRO, as I understand, I don't know exact information, but ISRO is also planning to watch this asteroids and nearby objects. They have started some efforts, at least optical observation. They are started monitoring some places that I am aware. Yeah. Everybody needs to watch them. Need to watch.
Thank you so much, sir. Sir, one last final comment from you, and then I'll take the final comment from Narendra sir to close up this discussion. It was a nice, amazing insight. Till date, whatever information I was getting from regarding asteroid, it was related to some impacts that have happened on it. But today you have showed us that yes, it can. There are some impacts on space, weather, too, and all. Thank you for that. So one final comment for the kids who have joined us, for the young kids.
Oh, for kids, okay, I always means for kids or for me also, even at this age, we should be always more passionate what you are doing and never trust, never believe whatever people say for your answer to your questions. Try to find out your own questions and their answers. Okay. So keep asking questions. Don't take granted whatever is taught. Suppose like I say now, okay, so sun has a 6,000-degree temperature. So you should have always question me. Come on, there is no thermometer flown to the sun and measure the 6,000-degree temperature. How do you know sitting here? So like that questions you should come, kids or any student who want to learn, keep asking questions and think creatively. I think that's a way to learn science and enjoy.
Thank you so much, sir. Thank you so much, Ankush, sir. Narendra, sir, final comments from you.
Well, I'm very happy to talk to this group. And there are more questions about meteorites than about anything else. So I thought I'll show you one meteorite which I have collected.
Wow.
So you probably, I don't know how many you had chance to see meteorite, but this is the one, you know, it has black crust and inside is gray. I hope you can see, we have broken a little edge here. So there's a crust, and I think some people are asking how to identify meteorites. Well, that's another discussion. But the message I would like to give is that by doing simple things, not very complicated machines and sending missions to Mars and all that, we can learn, of course, lots of things. But there are ways in which by doing simple things, we can learn a great thing, a large thing. And one such thing is if you can catch hold of a meteorite, or you look at a celestial phenomenon in the sky. So all your children who are there, I'm very excited to have this audience. They should look at the sky. They keep on looking at the sky, you will find something new. And you know, the only live supernova explosion was witnessed not by professionals with large telescopes, but by an amateur who used to go up his roof and look at a little telescope. And one night he found that a star has blown and disappeared or shining brightly. And that was the live supernova, and that is a big discovery. So by looking at the sky itself, you can learn lots of things. And of course, there is no comparison with any other experience in life than to hold a cosmic body in your hand. Thank you very much. I enjoyed it.
You're welcome, sir. And sir, just to end the session with the kids and with everyone, I request all of you that please turn on your camera, all the students. Let's take a group photograph and then we'll end up our session. Let's see all the smiling faces over here. Narendra sir and Ankush sir, very soon we are going to connect with you for future discussions. Okay, see, you have said yourself that it will take a whole lot of hour. So we'll discuss more about the asteroids in our coming session. Everyone, I guess, okay. Yes, now you all can turn on your cameras. Thomasina ma'am, is it possible for kids to turn on their camera?
It is. I have clicked on that. Yes, they should be.
Yes, now they can.
Yes.
All right, nice to see faces. Yeah.
So it's only the constraint of time. Kids have sent more than 100 plus questions I have actually from the kids. Most of them, though, they are repetitive. And 80% of them, I would say, they have been covered up in the interaction. But still, kids are the most curious ones in the whole world. Okay, everyone. Yes, everyone. Turn on your cameras. It's a time for group photograph. I'll wait for 5 more seconds. That's all.
So whilst we're waiting for kids to turn on their camera, on behalf of the museum, I would like to thank Dr. Ankush, Dr. Narendra Bhandari, and Space Outreach India. Thank you for this wonderful session. And I hope all you kids are ready. Yes, so we can take a screenshot.
Yeah.
Wow. Everyone, just be on the screen with the smiling face, and on the count of 3, right? So I'm going to start. 1, 2, and 3. Okay.
So if all of you had a great time, you can show a thumbs up. Yes. Yes. Thank you. Thank you very much. Thank you, everybody. Thank you once again.
It was very nice.
Thank you so much, ma'am. All handed over to you.
So, goodbye, everybody. And see you at 6 o'clock on the YouTube panel discussion with young astronomers. So, bye-bye, everybody. Goodbye.
Recording.
everybody, and see you at 6 o'clock on the YouTube panel discussion with young astronomers. So, bye bye, everybody. Goodbye.
Recording.